Hello, this is Jared Fellenbaum, and my partner is Tossin. We are presenting dual core with two-way superscalar pipelines with inter-processor communication in Logisim for advanced computer engineering for Dr. Wunderlich. So what you're looking at right now is one of our cores. We have two pipes, so marked by the top, control logic pipe, and then second pipe, pipe 2, marked by the stack control logic. Alright, so what this does is takes in data in the form of binary digits as opcode and operands, which then we break down right here through a register for each pipe. The top pipe gets 12 bits and the bottom pipe gets 12 bits as well. Those bits are then broken down again into 4 and 8, so 4 for the opcode and 8 for the operand for each pipe. So what that looks like is right here. That would be the opcode that you're looking at, marked by this hexadecimal display, and this is our operand coming from the broken down mux. Alright, so what it does exactly, each opcode is unique, so we have 4-bit opcode 0000 through 1111, and I'll go through each of those. So right now I have preset to the opcode for the top is 0110. The opcode for the bottom is 1110. Each of those has specific and unique functionality. So the top, what we're doing is we're ORing the immediate data with counter 1. So labeled counter 1, immediate data is the operand coming through. So we'll be ORing the operand with counter 1. Our OR display is right here, so you can clearly see that it's registering. And the bottom pipe is 1110, which registers as E in hexadecimal. And what that's doing is writing to our general purpose register into our mux to get to shared memory, which will then be looped back and through another opcode read as the operand up here. So right now I have the operand at all ones, so that'd be FF, and what that signifies right now is the shared memory. We were unsuccessful of getting the communication between the cores and the beginning of shared memory to work, but I will display it in this manner. So, as I said, we are writing to the shared memory right now, but if I change the opcode or the data input to read from the memory, from the shared memory, I will show you right now. So fetch, decode, execute, and wait are all part of our finite state machine. Reason why it's not hooked up is because in our core, or in our dual core, we have our finite state machine, which is running a RAM and a clock, essentially, to switch the data, and that is generating it instead of this, which really is doing nothing. It's just there for purpose. So anyways, back to the opcode and shared memory. So I will decode this. So that takes in the new data, which is 90FFA6. Leave that on. We will execute that through both of our registers and muxes. And as you can clearly see, the F has gone through down here. So the first right here is the opcode, the first digit, and then the second two digits are the operand. However, since the opcode is instructed to read from the shared memory here instead of the general memory or original memory, both pipes display operand FF up here as well, instead of what would originally come through is 90 and FA. So if I change this, there we have F7 for both, reading 67, 37, back up to 97, and back up to FF. So I will change the opcode now to display the top reading, or the top pipe opcode as an F instead of the bottom pipe. So this is still the same thing. We have F opcode and 5 opcode, and again they're both reading from the shared memory. This is happening, or would be happening, in our dual cores, because this is just a functional block for the main. However, we were unsuccessful to get it functionally working functionally. And this, as you can see, it's deciding which core to write to. That essentially means it's telling the mux which shared memory, which pipe accumulators is it reading from. Back into our main. So I showed the opcode F, or 1111, as you can see here, for both pipes, and displayed perfectly. Our up and down counters. Again, those are to compare, add, or, and sum to the accumulator, which is right here. We have 2 accumulators, one for each pipe, display at the end, and then they will be muxed into our final register. And this enable is showing that opcode 1 is an F, or opcode 1 is 1111, enabling the shared memory to go through the mux instead of the opcode or operand that would originally go through. So I'll show you that. I'll change the operand, the opcode for pipe 1 back to its regular form, and then we'll read from back to something other than F. So here it will be 6 and 5. So 6 for the top pipe and 5 for the bottom pipe again. And instead of reading F, 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 it's reading DB and 9, 0 for the bottom pipe. And like I said, we were unable to get this working in the cores, and ultimately interprocessor communication. So that is the end of our display and presentation. Thank you for joining. I hope you learned something about dual cores and two-way superscalar pipelines with interprocessor communication.